Hi guys, welcome back to my channel. So today I'll be making a short video on Laplace transform. In my next video I'll be making a video on Elzaki transform. And okay, for now I just want to explain something important under Laplace transform, the table. Then in my next video I'll explain better how you can get all this Laplace transform. So for now we have the table of Laplace transform, and I said you should take note of these two things, which are very important because I'll be using it to explain some things to you. You can know this table without memorizing. You just have to know a few things that are important. So the first one is Laplace of f of t. Your f of t is just like an input function, and then you're going to have f of s, which is your Laplace. So suppose I have f of t, which is all this I have here, then if I'm looking for my Laplace of f of t, I'll have what I have the right hand side. So let me start with something simple. If you have f of t to be 1, then you're looking for Laplace of 1. Laplace of 1 will be 1 over s. In my next video I'll be explaining how you can get this because it has a proof. So Laplace of e raised to power at, you just have to take note of something important, which is whatever you have here. So this is minus a, so it's going to be plus e raised to power at. So Laplace of e raised to power at is 1 over s minus a. So if I take the inverse Laplace of this, so that is, if I say inverse Laplace of 1 over s minus a, which implies I'll have e raised to power at. So inverse of whatever you have here will give you what you have here, and Laplace of whatever you have here will give you what you have on the right hand side in the table. So the way you're going to know is if you look at what you have here, your constant. If you have minus a here, it will be e raised to power at. If I have 1 over s plus a, and I'm to take the inverse Laplace of this, it's going to be e raised to power minus 80. So opposite of the sign that you have here. So Laplace of sine 80 is a s squared plus a squared. So that of sine and cos are the same thing, are similar. Sorry. So the only difference you have is what you have here. So for cos, how you just have to know it is you have s here, right? So for cos you have s to for the numerator. Sorry. So cos 80, so it will be s over s squared plus a squared. If you're working with sine, it will be a over s squared plus a squared. Can you see the difference? Now if it is hyperbolic cos, all you just need to know is the sign will change. Instead of plus that you have here, you'll be having minus. Similarly for hyperbolic sine. So sorry, this should be hyperbolic sine. Yep. Now for this is what I want to really explain, which is the main reason I'm doing this video. You have e raised to power at cos bt. You have to find the Laplace of e raised to power at cos bt. What you just need to know at first is, from here, in the beginning, I said Laplace of f of t is what? F of s. That is why when I did Laplace of sine 80, I had a over s squared plus a. I had s. So whatever I have here is what I'll be having as my s. Now, but for Laplace of e raised to power 80 f of t, I have f of s minus a. That means instead of me having s, wherever I have s, I'll be having s minus a. So here, Laplace of sine e raised to power 80 sine bt. Let me just do the Laplace of sine bt first. So if I do Laplace of sine bt, I'll have normally b over s squared plus b squared, using what I've given you in the table before. So if I now want to do e raised to power 80 sine bt, it is the same thing as e raised to power 80 f of t. But here, my f of t is what? The sine bt. So it implies anywhere I have s, like I said, when I did Laplace of f of t, I had is equal to f of s. That's why here I just have s, s, and a. But if I'm doing e raised to power 80 f of t, like this is representing my f of t. So e raised to power 80 cos bt, I'll just expand this normally. Let me explain with sine first. E raised to power 80 sine bt. I expand sine normally, and if you expand sine normally, what are you going to have for sine? It will be b over s squared plus what? B squared, right? But this time around, it is e raised to power 80 sine bt. So we'll use this. Instead of having s, anywhere I have s, I'll put what? S minus a. So that's why here I have it to be s minus a squared instead of normal s that you have here, plus b squared b. So what if I want to work with cos. Yeah, for cos, you just remember that, okay, a Laplace of cos bt is what? S over s squared plus b squared. So it implies if I have Laplace of cos bt to be this, all I have to do is to change s to be what? S minus a. Yeah, correct. So s minus a over s minus a all squared plus b squared. So that is all on Laplace transform for the table. We have other functions, but this is like the main function you need if you want to like go for any test or exam. They are really, really important as you'll be needing them. So here, if you want to do, if you have f prime of t and you're looking for Laplace of f prime of t, this is just the same thing as let me say I have y prime. So my y prime is dy dx, right? So y prime of t. So let's say I have f prime of t. So Laplace of f prime of t will be s f of s minus f of 0. If I had it to be Laplace of y prime, that would just be sy, because we're working with y. So sy of what? S minus y of what? 0. So because I use f here does not mean you cannot use any other variable. So Laplace of y prime prime will then be s squared y of s minus sy of 0 minus y prime of 0. So if you notice, this is just going in descending order. You have squared here. Yeah, the power here is what? 1. And the power here will just be s raised to power 0. And anything raised to power 0 is what? 1. That's why we have this to be this. So that's just all on the table of Laplace transform that I want to explain. Like I said, there are other functions, but we'll just stop here today. And in my next video, I'll explain how we got this and some other interesting things. Anticipate the video for Elzaki, because I'll be explaining how to work on Elzaki transform. Thank you so much for watching. If you do enjoy what I just explained, kindly subscribe to my channel and turn on your notification bell to get notified immediately I upload any other video. Thank you and have a nice day.